Hello students, welcome to Kittle Pure Science College online classes. Today in this class we are going to understand the concept of Carnot Engine from the chapter Thermodynamics. Before going to understand the what is Carnot Engine, how it works and its efficiency, let us know in brief the heat engine. Because heat engine is being deleted from the syllabus, but to understand the Carnot engine easily, let us know in brief the heat engine. Heat engine is a device which is converts the heat into useful work. Heat engine consists of source, sink, working substance, insulating stand. So source is nothing but it is a material which is kept at a high temperature and having infinite thermal capacity. At the same time, zinc is a material which is kept at a low temperature and having infinite thermal capacity. And also in source, any amount of heat can be taken from it without changing its temperature. Similarly, any amount can be given to the sink without changing its temperature. Next one is working substance. It is a material which converts heat energy into a useful work. It is taken in a cylinder fitted with a movable frictionless piston, and the base is thermally conducting or perfectly conducting. And last one is insulating stand, which insulates the working substance from thermal contact with the surroundings. That is, it is used to perform the adiabatic process. These are the main parts of a heat engine. Next, how the heat engine works. So, whenever the heat is given to the source, here you can see here it is a diagram of a heat engine. So, this is the source working substance and it is a sink. So, whenever the heat is given to the source, it is sent to the working substance, where the working substance absorbs the heat from the source and it is utilizes the heat and converts the heat into useful work, and remaining heat it sends to the sinks or it rejects to the sinks. This is the how the heat engine works. Now let us move to the main concept of today's class, that is Carnot engine. Carnot engine is an ideal heat engine which has been proposed by the scientist Leonard Carnot. So it has a maximum efficiency, uh, and ideal gas is being used as a working substance. This is about a Carnot engine. Though we had a heat engine, but Leonard Carnot has proposed a engine or invented a engine where it can give a maximum efficiency, and this engine is also works under the reversible condition. This engine is a reversible engine and it gives the more efficiency. And we have a Carnot cycle. So this device is, that is Carnot engine, is under a cyclic process. That is, Carnot devised a ideal gas cycle of operation of a heat engine and named it as a Carnot cycle. So if it completes one cycle of operation, it requires 4 thermodynamic processes. Let us see what are those 4 thermodynamic processes in detail. First one is isothermal expansion. Here we can see the what is isothermal expansion. In isothermal expansion, we can see here, as I've said, in heat engine we have used 4 main parts, that is source, working substance, sink and stand. The same process is being used in the Carnot engine. The same parts is being used in the Carnot engine. So this is the first cyclic process, that is isothermal expansion. Second one is adiabatic expansion. Third one is isothermal compression, and fourth one is adiabatic compression. So let us see in detail these cyclic process, that is operations which takes place in a Carnot engine. First one is isothermal expansion. In previous class, I have already explained you what is isothermal process, adiabatic process. So you have to go through those processes once again to know in detail, to understand better the what is isothermal expansion. So in isothermal expansion or isothermal process, it is a slow process in which temperature is kept constant. So isothermal expansion, here in isothermal expansion, first the working substance is kept, that is a cylinder which is fitted with a frictionless piston is placed on the source. So first step is that we have to place the cylinder on a source. So the piston of a cylinder is moved outwards, that is because of the gas expands. Here the temperature is kept constant because it is a isothermal process and it is expanding, that is expansion is taking place. The amount of heat absorbed, so the amount of heat from the source will be absorbed to make the temperature constant. As the temperature is kept constant, since the gas is expanding, its volume increases and pressure decreases. And this isothermal expansion is being represented with the help of PV diagram. Here you can see the PV diagram, that is pressure versus volume. So here AB curve indicates the isothermal expansion. Initially the cylinder is filled with the ideal gas. Here one more thing, Carnot engine is a theoretical thermodynamic cycle which is a hypothetical, means the working substance what we are taking, that is the cylinder which is fitted with the frictionless piston, and the working substance is taken as a ideal gas. It is filled with an ideal gas. So its pressure, initial pressure is P1, volume is V1, temperature is T1. So after it gets expand, pressure decreases from P1 to P2, volume increases from V1 to V2, and temperature remains constant. This is the isothermal expansion. We can see just a isothermal expansion PV diagram. Next is adiabatic expansion. Adiabatic expansion means it is in adiabatic process, it is a very fast process where pressure, volume, temperature keeps changing, but heat does not exchange with system and surrounding. In short, we say that heat is kept constant. Here in second step, the working substance, that is the cylinder, is now removed from the source and it is placed on the insulating stand. So now it has been placed on the insulating stand. The lower conducting side of the cylinder, that is which is kept on an insulating stand, the piston of the cylinder is moved outwards. So when it is kept on an insulating stand, there is no exchange of heat takes place. So the gas expands with the help of its internal energy. Here the heat is not going to get exchanged. Heat is remained constant. But after keeping the heat constant, still there is a expansion of gas takes place. That is because of the the cylinder is utilizing its internal energy to get expand. So when the gas expands, the volume increases and pressure decreases, and also temperature decreases from T1 to T2. So here is the PV diagram, that is pressure versus volume diagram. Here in this diagram, AB is a isothermal expansion, which we have seen in a previous slide, and BC is the adiabatic expansion. And you can see here in isothermal expansion, pressure has been decreased from P1 to P2, volume has increased from V1 to V2, temperature remained constant from T1 to T2. And in adiabatic expansion, pressure decreases from P1 to P3, volume increases from V1 to V3, temperature also decreases from T1 to T2. This is about the adiabatic expansion. Next is isothermal compression. This is the third step of a cyclic operation or a series of process, that is isothermal compression. In isothermal compression, so in first step we have placed the cylinder on a source. Next we placed it on a insulating stand. Now we remove it from the insulating stand and we are placing it on a sink. Here we can see in this diagram, the cylinder is kept on the sink, and we know that sink is having the low temperature but with a high thermal capacity. So now the gas is compressed. Here isothermal means temperature is remain constant, and this process is so slow that the gas in the cylinder get compressed. It get compressed. The excess heat will be rejected towards the sink. The excess heat will be rejected towards the sink by keeping the temperature constant. Here since it is compressed, the volume is going to decrease and pressure is going to increase, and this can be represented in the PV indicator diagram through the curve CD. This is the isothermal compression. So as I have said you, AB is isothermal expansion, BC is the adiabatic expansion, and CD is the isothermal compression. In isothermal compression, pressure is going to increase from P3 to P4, volume is going to decrease from V3 to V4, and temperature remains constant because it is an isothermal compression. Next, the last operation is adiabatic compression. So adiabatic compression, now it is the last step of a cyclic process. Now we have to remove the cylinder from the sink and we have to place again on the insulating stand. Here in this picture you can see that the cylinder is placed on an insulating stand. Adiabatic process, as I have said you, it is a very fast process and there is no exchange of heat takes place. So now the gas is compressed. The gas is compressed, as such there is no heat enters or the leaves from the system. There is no exchange of heat. Either it is going to gain the heat or it is going to reject the heat. In this, while it is compressed, volume is the gas volume is get reduces or decreases, and same pressure is going to increases, along with the temperature is going to increase from T2 to T1. So in this diagram you can see dA is the adiabatic compression. The curve dA is the adiabatic compression. So here you can see that the pressure P4 increases to P1, whereas V4, that is volume, falls to V4 to V1, that is decreases, and whereas temperature also increases from T1 to T2. From this diagram, PV diagram, we can see that it has comes to its initial state. So AB is a isothermal expansion, BC is the adiabatic expansion, and CD is the isothermal compression, and AD is the adiabatic compression. These are the 4 steps which undergoes in the Carnot engine. working of an Carnot engine, and this complete cycle is known as Carnot cycle. This is the complete view of a Carnot cycle, which I have explained one by one till now. So here I'll just brief off the Carnot cycle. So initially, as I've said, in first step in isothermal expansion, the cylinder is kept on the source where pressure falls from P1 to P2, volume increases from V1 to V2, temperature remains constant. That curve is represented by AB. Next, the cylinder is removed from the source and it is kept on the insulating stand where it undergoes a adiabatic expansion. There also the pressure falls from P2 to P3, volume increases from V2 to V3, and temperature increases from T1 to T3, and BC curve indicates adiabatic expansion. Now at the third step, we are going to remove the cylinder from the insulating stand and we are going to place it on a sink where it undergoes a isothermal compression. So CD curve indicates isothermal compression where pressure increases from P3 to P4, volume falls from V3 to V2, and temperature remains constant. Next, now we are going to remove the cylinder from the sink and placing again back on the insulating stand where it undergoes a process that is adiabatic compression. So DA curve indicates the adiabatic compression. Here we see that the pressure increases from P4 to P1, volume decreases from V4 to V1, and temperature increases from V2 to V1. So it finally comes to initial state, and this complete cycle is called as Carnot cycle. I hope the Carnot engine, its parts, its working, and series of operation and Carnot cycle with PV diagram is clear for you. Next, last is efficiency of Carnot engine. So we know that efficiency is nothing but it is the work done to the heat supplied. Work done to the heat supplied. Here in first law of thermodynamics, its applications, we have already learnt the isothermal process, adiabatic process, and also we have derived the expressions for work done in a isothermal process, work done at a adiabatic process. Using those expressions, we are going to derive the expression for the efficiency of the Carnot engine. So here this is the symbol of a efficiency, which is known as neta, which is equals to work done by the heat supplied. So here work done can be written as it is nothing but Q1 minus Q2, where Q1 is the amount of heat absorbed from the source, whereas Q2 is the amount of heat rejected to the sink. That is, the Carnot engine works in between the two temperatures. Therefore, efficiency will be, so work done is represented as Q1 minus Q2 divided by Q1, right? So here work done is nothing but Q1 minus Q2 divided by Q1, which is equals to 1 minus Q2 by Q1. So for Carnot engine, it can be written as, this is in terms of heat, it can be written as in terms of temperature as efficiency equal to 1 minus T2 by T1, where T1 is the temperature of source and T2 is the temperature of sink. This is one way of finding the efficiency of heat engine, and in other way also we can find the expression for the Carnot engine by using the expression of a work done in a isothermal process and expression using the work done at a adiabatic process. Using those expression, we can arrive the expression as 1 minus T2 by T1. So this completes the concept of Carnot engine, which is the last concept of Carnot engine, and in next class we are going to continue with a new chapter. Okay, stay home, stay safe. Thank you.